Hey everyone, just a new video to show you all the new bidirectional controller we've put together. Basically, this is a PCB model that I've just slapped together to show everyone how it all works. It's identical to this model, except obviously this one has a nice metal case. Pretty good quality, good controllers that work well. Now, I've got this one bare bones so you can see how everything works and how I do everything. Now, all models are the same. You've got a Model A, a Model B and a Model C. And where they differentiate is the control options. A Model A and Model B are good for potentiometers or Hall effect throttles. Either hand or foot, it doesn't matter, because the control method is basically 0 to 100% with Model A and Model B. So that's any control that goes from 0 to 100%. Model C is a little different because Model C basically the center point of your control is off, and if you start to turn it, the speed will increase one way. But if you go back to the center position and you increase it in the anti-clockwise direction rather than the clockwise, the motor will go backwards at the speed you set here. So you've got 0, 100% left and 0 to 100% right. So it's not really suitable for a Hall effect throttle, because a Hall effect throttle always wants to go back to its 0 position. And the controller on a Model C, if you tried to use this, it would see the center point as off. So because the control flicks back, it would always be going full speed in the wrong direction. So that's why a Model A and Model B is suitable for Hall effects and potentiometers. Now I'm going to show you how they hook up, and they all hook up the same. Basically, you've got two connections for each connection here. So you've got 2 for motor positive, 2 for battery positive, 2 for battery negative, and 2 for motor negative. So without further ado, let's hook this all up. All the models are the same except for that IC. That's the only thing that changes between the 3 models. Just one chip. Everything's done in software. Alright, now let's go from the top. First we put in our motor positive. Now, if we had a really big motor that was 50 amps and it had thicker wires than this, then we could either split the wires into 2 and run one into both of them to share the current. The reason we want to use 2 if we have greater than 25 amps is because each of these little terminals can only take about 30 amps. Past that, they start to get hot, so you don't want to do that. That's why we split it. They share the load and they don't get anywhere near as hot. They don't really get hot at all. Okay, so back to our connections. So we've got our motor positive hooked up here. As you can see, these first 2 are our motor positive and the bottom 2 are our motor negative. Now the second 2, 3 and 4, are our battery positive. So we use these dodgy alligator clips and we hope to God they stay on, because generally they fall off. So we know that 3 and 4 are our battery positive, and we know that 5 and 6 are our battery negative. So that's our motor connections for that way. Now let's just hope they stay together while I turn this around. Now the first model I'm going to show you is Model A. So with Model A, we can see from our instructions here that it goes from 0 to 100%. It has push button braking and push button reverse. It's suitable for hand throttles, foot throttles and potentiometers. So push button braking and push button reverse. So we want 2 momentary switches. So that's a momentary. That's a momentary. So let's put these in. That's 1. That's 2. So that's switch 1. that's switch 2. Okay, these next 3 are for the current limit. Now, all the boards have this, but it's not actively used unless you take this trim pot out. This trim pot is internal, and basically you can adjust your current limit from here. Now, if you need to have a potentiometer here, then basically you need a I think it's a 10k potentiometer, but I'll confirm that. You basically put a 10k pot here and you'd cut this off the board, because you can't have the 2 on at once. It wasn't made to do that. Okay, the next 3 are our control. Now, control can either take a potentiometer, in this case yes, it can take a joystick, it can take quite a lot of different types of controls. But starting off with model A, let's use that one first and see how it goes. Now, we need an on-off switch, so we'll use one of these latching ones I have here. A latching switch is push on and then push again to turn off. Let's get it in there and fire this thing up. Okay, our on-off button is there, our switch is there, our second switch is there. Make sure our potentiometer is at 0 so the motor doesn't take off. Make sure our current limit is not set too low. Double check our battery connection, so we've got motor positive, then we've got battery positive, then we've got battery negative, and then we've got motor negative. Those are all correct. We're ready to fire up. Okay, let's just power it on. Okay, our potentiometer doesn't start until quite late, so we may need to adjust the controller. So basically, to adjust the controller, you've got 2 settings that can be programmed in all of the controllers, and they are the control method, which is always done on switch 1, and the soft start, which is always done on switch 2. Now, this pot doesn't start till, well, a quarter turn in, and maxes out about the same. So we're missing a bit of range there, which we'd like to get back. So we turn the controller off. We don't need to turn the power off for this. Now we need to enter programming mode. So we turn this down. It's got to be all the way anti-clockwise. Don't try and force it past where it stops. And to get into control mode programming, remember it's done through switch 1. So we hold switch 1 down while we power the unit on. We hold it for 3 seconds, then we turn the control in its full range from start to finish. Now it's important to do this quickly. Just go back and forth. That way the controller learns where the start and end positions are. So we make sure that's back to 0. We turn the current limit back up so the motor will move, and now our range is much greater. There you go. Now, if we want to use a Hall throttle with this, the difference between a Hall effect throttle and a potentiometer is the voltage. So if you try and hook a potentiometer up to a controller that's designed for a Hall effect throttle, you'll find the same thing as before. You'll lose half of your movement. So the potentiometer won't start until it's probably at 11 o'clock and will max out at maybe 4 or 5. You lose a lot of your range. That's because this works from 0 to 5, but this works from 0.6 to 4.2 or 4.3 or something like that. So most of your range is gone. Now if you try and plug a Hall effect device into a unit that's designed for a potentiometer, the opposite happens. Because your range is higher and your max is lower, the controller will instantly think that you've started to turn the throttle, and I'll show you that. So let's switch this off. Now power the controller down, and let's unplug our potentiometer and plug in our throttle. Bear with me here. Of course it's temperamental. I should have probably soldered these to make the wires a bit more rigid. So that'll work just to demonstrate. Okay, it looks like it's going to work. Alright, now let's power it on. Now straight away you can see that the motor's started moving by itself. Worse still is that we can't get it to maximum speed. That's as high as we can get it. And that's for the reasons I told you before. This doesn't have the full voltage range. So we need to program it. So again, we switch it off. Now to get into programming, we turn it back to anti-clockwise all the way. Now we hold on button 1 while we turn the power on. Now we hold it for 3 seconds, and then we quickly show it the full range. Now this doesn't have much of a range, but that's what they're like for Hall effect hand throttles. Alright, so let's turn our current limit back up. Now you'll notice our motor isn't moving. But that's because the controller now knows where the start position of this is. So now you also notice with this controller, Model A is a push button. Oh, that's a brake. So the motor is changing directions as we push the button. Now Model B is completely different. Model B doesn't have a brake at all. Model B uses a latching switch. So unlike this one, which you push, push, push and the direction changes, with Model B it uses a latching switch. So you have to hold the button down for it to stay into reverse. But I'll go over that. So that's that one. As you can see, we push the button, we change direction. Now it will remember the direction you left it in. It will also remember the program settings. So for example, if you've got a potentiometer on this and it's set to this speed and this direction and you lose power, as soon as the power comes back on, it will resume right where it left off. Now you've also got a soft start mode, which again is programmed the same on all models, and that's with switch 2. So if you can see this, there is absolutely no soft start between those. Now on a big motor, that's a really bad thing to have, because if you've got a big motor that slams into reverse and then it tries to actually move, your current draw will be massive and it's going to kill your controller real quick, unless your motor is small and your controller is way overpowered for it, which in this case it actually is. So we can get away with that. Now I'm going to show you how to get it into soft start mode. So again, we turn the power off, we turn the current limit all the way to 0, which is all the way anti-clockwise. Now instead of holding switch 1 like we did to teach it how to accept the controller, now we're going to hold on to switch 2 while we turn it on. Now instead of the 3 seconds, we hold it for 10 seconds. Now that should have enabled the soft start. Let's check it out. So now you'll notice it doesn't just straight away change. It slowly ramps it up with each time you change the direction or whenever you apply the brake. Okay, switch it off again and I'll just put the potentiometer back in there. Now I will also work with foot throttles, and the programming is the same, because a hand throttle and a foot throttle in a Hall effect device are actually different again. I don't know why there's so many variations, but there is. All hand throttles seem to have the same voltage, but foot throttles are just different. We've got 2 different foot throttles and both of them have different voltages. But regardless, that's the way it is, that's the way it is. Okay, let's chuck our potentiometer back in there and we'll screw that up. And now that's all done up, let me show you Model B. So we take this IC out and we put the Model B IC in. Now the Model B, if you look here, whereas Model A, the one we just looked at, has push button braking and push button reverse, the Model B has a toggle switch for reverse. So the reverse will only stay active for as long as the toggle switch is on. Now it's good for, same as A, Hall effect throttles, Hall effect foot throttles and potentiometers. And one more thing I forgot to mention with A, you can't press both of the buttons at the same time. Now if you push a brake in panic and you try and push reverse at the same time, it will always prioritize the brake over the reverse. So in a panic mode where you try and hit both at once, the brake's going to be the one that wins out. So okay, that's all covered now. So let's have a look at Model B. Now Model B uses a latching switch on the reverse rather than a momentary switch. So let's try it. Okay, we'll leave this here because that's our on-off. That needs to be a toggle switch. And we'll remove, what's that one? It's a momentary. And this one is also a momentary. And we have a latching here. Now Model A comes with 2 momentary switches. Model B only comes with 1 switch. So if you need to program it, you still have access to both the buttons at the very start when you turn it on and you've got the current limit switched all the way anti-clockwise. So even though a model will only have 1 button with it, you'll just have to put another button in there, short it out somehow, because that's all this button does, just short each one out. So switch 1 shorts these 2 out, and switch 2 shorts these 2 out. It's that simple. Alright, now we've got a latching button. We've got Model B chip in place. Everything's correct here. Let's switch it on, make sure it's all the way down. Okay. Now you can see we've got the problem again where we only have a very small amount of active range, which is kind of dodgy. I must have set this up for something else. So the controller goes from there to their maximum. So maybe I don't know, maybe a 15-degree turn. That's not much at all. So we need to reprogram that so the controller can see the full range. We can do that quickly, so I can cover that with you. So again, power off, all the way anti-clockwise. Now we've got to hold this button down 3 seconds while we power it on. So 1, 2, 3. Now let's turn it so it gets the full range. Now once it has the full range, again let's turn this up. The reason there's a range change is because we changed the chip from Model A to Model B. So now you can see we have our full range back. And that's what we want. Now I'll show you this one, Model B. You'll see our latching switch. The reverse will only come on while the switch is on. So that switch is now off. Now that switch is on. That's off. Now I'll just slow that down so you can actually see the speed changing on the motor. Now the soft start hasn't been enabled on this. So if we wanted to turn the soft start on, we'd have to short these two out while we powered it on. And that would give us our soft start. But that's Model B. Now it can be used with throttles again. Hand throttles, foot throttles and potentiometers. And it has the latching switch for reverse. It doesn't have a brake as such, but the reality is it doesn't really need one because it's also got a brake in it. So if your motor's going at say full speed and you've got this in a cart or a buggy and you drop the throttle straight away, the brake will apply from the moment you start decelerating. So if you're going down a hill and you've got the controller turned down, then in the off cycles of the PWM, the motor is acting as a generator. So it's actually braking as you decelerate. And that is Model B. Now, you just switch this off and we'll have a look at Model C. Now, Model C is different again. So if you've got the potentiometer turned all the way anti-clockwise, then you're going to be going full speed in the reverse direction. If you've got the potentiometer centered, then you're going to be at off position. If you've got the potentiometer all the way clockwise, then you're going to be at full speed in the forward direction. So the button on this is only braking. Now, even though you've only got one switch here and you've only got one switch in Model B as well, if you put that switch into switch 1 or switch 2, it will still act as a reverse switch regardless of which one it's in. That's the same with this. You've got input 1 and input 2, but both of them will do the same thing. They're both push button braking. So without further ado, let's plug in Model C and see how it works. Okay, we make sure we've got it turned off. We'll take the IC out. We've done this many times, so we've practiced at it. Make sure the direction's right. Put the IC in. Now, for Model C, we know 50% is going to be our off mark. So we want to put the potentiometer in 50%. Now, we don't know what this chip has been programmed to before because I've been testing with it. And we know both the buttons will act as a brake. Now that's a latching one, so we probably don't want that in there because it means as long as we have it on, the brake is on. I mean, you could do it that way if you wanted to. Actually, I suppose we can. Yeah, for the sake of demonstration, oh, actually no, I won't. I'll take that out because I don't want to confuse people when they get a momentary switch in the package when they order a version C. So let's chuck that in there. We do it this way, we cover it once and we don't get people confused. Alright, so once again, we make sure our potentiometer is at 50%, we check our plugs, we check our wiring, everything seems okay, I think we're ready to fire up. So let's do this. Okay, now straight away you can see as I turn the controller anti-clockwise, the motor is actually going clockwise. And you might think, well, hang on, I don't want it to do that. I actually want it to go anti-clockwise when I turn anti-clockwise. Now that's an easy fix. And for this one we'll take the power off because we don't want those alligator clips to slip. So all you do, this DC motor has polarity. It's a brushed motor, and all brushed motors are the same. If you swap the polarity, so instead of the red wire from the motor going to motor positive, we put it to motor negative, and we put the motor negative where motor positive was. So let's do that. We chuck the motor negative where the motor positive belongs, and we do the same, the motor positive, and put it onto the motor negative. It's such a simple thing, but so many people don't know or aren't sure. Excuse me, so they ask. So now we've got the terminals reversed, nothing fell off, everything's still in place. Let's turn our power back on. Now we power on, and suddenly we go anti-clockwise and our motor goes anti-clockwise. We go clockwise and our motor goes clockwise. Now this is programmed with a very small range. Again, that's probably 20 degrees from maximum in reverse to maximum in forward. Now again, I'll program it. So we put the current limit to O, we turn the power off on the controller from the switch, we hold the button down on the controller, and we turn the power on and we wait for 3 seconds. Then we start turning the controller from all the way backwards to all the way forwards. Now the controller will work out the front, or the start and the end positions, and then it will work out the center point from there. So let's turn our current limit back up. You need to have the current limit turned all the way down when you enter programming mode. If you don't, it won't enter. That's part of the conditions of entering programming mode, because I don't want somebody to have their hand on the brake or foot on the brake and then turn the controller off and back on. Because if you know, a wire comes loose momentarily, then you've entered programming mode and you don't want that. So that's part of the caveat. You've got to have that turned all the way down to access programming mode. So anyway, see, now we have a full range. It's much better. Alright, cool. Now I'll just show you the current limiting so you can see for yourself. Now say we have the controller going along, and let's get it right near the edge. Now you can see here, there's now a current limit on this. Now notice how we tried to go straight from 0 to flat out. If we gradually do it, the current draw will be slow, so we can get the motor up to a high point. Now the problem with this is that, see what we did? We've now caused the current to go over. Now because the motor is trying its hardest to pull as much current as it can to go quickly as fast as possible, it's being limited. So to get around that, we have to turn it up. That's how the current limiting works. Once you set it, the controller will shut down every time it reaches that point. So it's always got that ceiling. It can't go past it if the current limit's set. It'll just hit it, bounce back, turn off, turn on, turn off, and it will keep doing that and repeat. Now let's have a look at a different type of control option. Let's turn the controller off, and here we have a joystick. So let's plug it in and see what happens. Of course I already know what happens because I've done this 1,000 times before, but what's one more time? Alright, now with this connection here, you've got your plus 5 volts here in your first terminal, your differentiator, and your ground. So your power always needs to go to this first one. That's really important for Hall effect throttles, which I don't know if you can see, but we've got a red wire, a white wire, and a black wire. The ground is the black and always goes to this third terminal here. If you were to connect it up backwards, you could possibly either damage the controller or the Hall effect throttle, and you don't want to do that. Now some Hall effect throttles also have a green wire, so just be aware of that. Anyway, back to plugging in our joystick. I've also found with a lot of joysticks that they have very little range, and I've tested quite a few. but you'll see what I mean in a second. So we have our joystick now plugged in. Let's turn it on and see what we get. Now we've got no movement, which is a good thing. That means it's centered. But yeah, that's kind of unexciting and actually pretty depressing. What the hell? Okay, we have very little range in these, and I don't know why it is. I think it's just the design. Maybe they use standard potentiometers, pots. Let's program it. So again, we turn the power off, we turn the current limit down low, we hold our programming button, and we turn the power on, we hold it for 3 seconds, and let's go. That's all we need to do. Now we turn it back up, and that's a bit better. Nothing in the left and right, but if you add a second controller, then you can have a second motor and you can have full 2-axis. How cool is that? I know, it's awesome. Now, I didn't really know what to add here for switch 1 and 2 for this model, because basically, brake. You let it off, brake. This does the same thing. Brake, brake, brake. And there you have it. It's that simple to set up and use this controller. So just to quickly recap, we've got model A, which is great for Hall effect throttles, foot throttles, potentiometers, 0 to 100% speed. Model B is almost identical, except it doesn't have a brake like this one does, a push button brake. It has only a toggle switch for reverse. And again, good for hand throttles, foot throttles and pots. Model C is good for joysticks and potentiometers. It has 0 position off, all the way anti-clockwise is maximum speed, and all the way clockwise is forward maximum speed. That simple. If you have any queries, please don't hesitate to get in touch with us. We're always here to help. And all the best for whatever project you may undertake, and I hope you have fun building stuff, because yeah, we love seeing the projects you people come up with. Some of you are brilliant. Thank you very much. Have a nice evening.